Okay. So yesterday we looked at how to automate sending emails, and there are several things that you can do within email context. So what we did was to understand the protocols. So this is like generic, so protocols. So and then we also looked at what does a network protocol mean, and when you look at your open ports, we also looked at like TCP open ports, just to give an example. So how the traffic gets routed via that particular protocol. And then specifically we also looked at SMTP protocol, and um, we saw what is the port number and what it takes. And we looked at um, email servers, and then specifically we looked at Gmail, which is Google's mail service. And then we wrote code after this, and we are able to successfully send a mail. We also looked at authentication mechanism provided. So generally it is username and password. So Gmail additionally has app password. So it's sort of um, thinks the client program as clients and application. And with that application, you can also generate a password and use that instead of your own password. So that is what we did yesterday. So that is an additional feature by Google, but it's not related to the bare minimum um, or the traditional email. Okay. So yeah, so we also looked at history and stuff like that. Okay, so we have learned about few things now. So automating calendar, automating emails, and web scraping and things like that. So now you should be able to build your project. So in today's class, we will look at an important concept called as code quality. So why it is required, and what are the things that goes in for a good code quality in general. Okay, and then we will specifically look at what are the types of tests that we do, what are the teams that is involved, and how does in corporate, how do we build software professionally, and yeah, how you can make sure you can do the similar thing in your code. Of course, you can run an app all by yourself. There are like several single person apps that you can download. So but the process is the same thing. So unless you have this process in place, it's difficult to track the code changes and the existing features and so on. Okay, so let us get started with code quality. I'll start with testing, and then let us move on to code coverage. What is code coverage and logging? So these are the couple of topics that we'll discuss today. So what comes to your mind when we speak about testing? So generally, when you think about testing, so it's like you have the code, which is your artifactory. Artifactory in sense, which is your output of your project, which is the actual thing that is going to run on some server. Okay, so you had requirement documents, you had the HLT documents, which is high level design and low level design, and all these things are done, and then you have produced the code now. So once you produce this code runs somewhere. So before it is deployed, so process of the life cycle of a code is like this. So you write code, and the parts of the code are this. So if you have to like in Python, if you want to look specifically, it has got packages, it has got modules, and it has got within each module it could we did not cover object-oriented programming, but it could have classes. We'll cover that soon. And then it could have modules, which are just like .py files. Sorry, modules is already there, and functions. Functions. Okay. So these are the typical, and maybe there are some configuration files which help program to pick up like JSON files and so on. Okay, configuration files. So if you look at any repository, so these are the things that you see on the repository, right? So at each of these levels, you can actually run some tests. So if you had to do manual testing, what would happen is you write a function, say function to add two numbers, just some, it takes in two parameters, A and B, and then it returns A plus B. Okay. So if you write this code, so what would you typically do is, without any automated testing, we will print the output of AB and see it ourselves, and verify whether the numbers that I'm providing it is getting summed up. Okay, like 2 plus 3 is equal to 5. Okay, so this is what is called as manual testing. You run the script and you have some inputs in your mind, and then you cross check whether this is correct or not. And then you may also come up with some automated way of testing. So you may write another module, which is a test add or something like this, .py, and then call that function, say add, and keep passing the values like 10, 20, and so on. So this is, you're just calling the function, and then you can also have if else conditions to verify whether this function is working or not, working as per my requirements. So you might write something like if add 1020 is equal to 30, then okay. So print okay. So you can write like, you can keep writing this. So this is like very trivial way or vague way to automate stuff. So from manual testing, you move to automated testing. So this is the basic concept of automated testing. So this part where we call the function and verify is called as assertion. Okay. So you can also write a piece of code here saying that if this fails, just exit from this program. So don't even bother to jump to next set of test cases. Okay. So in Python or in any language, so there are modules or libraries which helps us to automate the tests, and it has got a framework. So frameworks of testing, framework of testing framework. In Python, there are two popular testing libraries or frameworks. One is called Unittest. By default, this is installed when you install Python. So there is also one more thing called as PyTest. So these two things or two libraries are popular, and then you can use any one of them. We will see how we can write tests and how it looks like. So what are the features that is provided by framework? Okay. So let us get back to the code, and then let us realize what we just discussed. So this is an easy concept, but it is very important. We will come back to like why it is important, and you can see how these tests help in the long run. Okay, so this is our code. So I'll show you. So you don't have to, and copilots are really good in generating test codes. Okay, so I'm going to say I want to demonstrate unit testing with simple code which has add, multiply, uh, division functions, and another file test calc and simple code file called calc dot file. It's another function with test dot send. Use unit tests for tests. Okay, so we will see how it looks. And of course, you don't have to write any code. You shouldn't be writing any code from now on, right? So that is our goal. But you should be having a mental picture, generate the code, glance over it, verify it, build mechanisms which can automatically verify, and then get your app out or deploy as soon as possible. So that's the goal with AI. So let me just create a new folder so that um, demo test. Okay. I'll put calc.py here. Paste it here. These are the functions it has generated, which are like we know how these things, right? So already. So this is just to demonstrate testing calc.py. And then you take this code, and I'll explain what are these things, but just bear with me. Let me, you don't have to remember how to run this. Let me show. So you can ask like GPT to run the tests, which is it has already given. So I'm going to take this and paste it here. Okay. This test calc is not present because our file name we have given as test CLC. The copy. Just focus on this code base demo under demo test. Let me run it again. No body again. Test calc. Why is it? Okay, my present working directory is by AI April, which is this. I need to get into demo. Just run it again. Okay. You can see that it just executed all the test cases. And there is also verbose mode. Let me run this. So you can see that. So -v stands for verbose in this context. So you can see that you can also see there are like 4 test cases which are run, and these test cases are okay. So what does this mean is, let us go to calc.py, and these are the 4 functions: addition, multiplication, difference, and this is your source code. This is your the production code which actually runs. And we have written test file, this test file, in order to call this, make this module, which is calc.py, our production code or the code which runs. We have called it here, and we have used the functions which are inside that. So if I just click on that, it will go to add here. So let us try to understand this part of the code and then come back. How does this help? So that's our goal now. So this part you already know, import calc. So there's this particular line called Unittest. So which is a framework which we just discussed. So there are two major frameworks. Of course, you can write your own framework, but there is already existing libraries where you want to write your own, right? So what are the features of this is, so this is a typical template or typical way to call or utilize this unit test. So you create a class. We will discuss about object-oriented programming, and we'll discuss what exactly this means. So, but just to introduce you to classes, classes are nothing but blueprints for objects. Class is a blueprint. What do we mean by a blueprint is that when we used type function, inbuilt function on a variable, right? So in our, I think second class, I think, when we initiated a is equal to 10, initialized this variable, and when we did this, so you saw something like class int, something like this, the output of that. Okay. So every object, so this is an object, a is an object. So anything that you see in Python is object. So what does an object mean? As I have explained, object means there is attributes and there are functions on top of it. So I was giving an example of a book. Attributes are its color, number of pages, and so on. So there are several attributes, and functions are probably like open the book, close the book, read and mark the pages and mark the text or whatever. So these are the functions. Okay. So when you put this together, so how do you put in Python is using a class. So you can have a class, say for example, class book. If I have to class book, and you can create an empty class. So or without this braces. So we'll see the syntax. So you don't have to remember the syntax, but you can simply create a class book. And then you can have functions like this. So you can write functions like open, close. Of course, it will have def here. Yeah, you don't have to type it, but these are the functions: open, close, mark, and so on. So once you have these functions, and you will also have attributes somewhere written. So you can initialize attributes such as color of the book and so on. So once you write a class like this, so this is a blueprint. So with this, you can initialize any number of books. For example, I can say book. This is your type of the object, which is a book, which we have defined in class. And you can initialize. So this is just a blueprint, right? This is code. So, but when you create an object, that piece of memory is allocated on RAM. So that is what an object means. So it consumes space on the RAM. So you can create n number of objects. So I can say book B1, B2, B3, and so many books. And probably this will be used in another code called as book library. And you can create class these objects, books, and then you can delete those books and so on. Okay. So this is what class in a generic sense means. Okay. So I'll just demo the same class with book. So because we can do it very quickly. So write a class book with attributes. So I think it will understand with at least 5 attributes and functions open, close, mark, read, read. Also create a few objects of book. So this is all, once we understand the concept, just generate the code. You don't have to like remember the syntax, right? So let us take that and I'll demo what it means. So we are doing this to understand this particular thing. Okay. So let me create class here, book dot UI. In agent mode, it will create a file here automatically, so you don't have to copy paste. Okay. So you can see that it has thought about the book. And it has given these are the attributes. Okay. So every class or every blueprint that we are creating, it will have something called as init function, which is double underscore. So these are also called as dunder functions. So it's a shortcut. So either you can call it as internal functions or private functions, or it's like double underscore functions. So this is dunder functions. So what this means is, so every code that we use, right, is written by somebody else, and we are also going to create code that could be used by other developers. So in Python, so we tell other developers saying that this is an internal function. Don't uh, modify it, or be cautious before modifying it if the source code is available. So that is what is called as dunder function or internal function. So we have already seen it when we just typed, dir of a certain object. So we saw that dir of CA or dir of a module name. So we got a lot of functions, right? We did, I think, requests and JSON. These are the models that we used. And we also looked at what are the functions. Okay. So there are several dunder functions, which are internal functions. So this is one of the functions which actually creates, or this is the one of the first functions which gets called when we create an object. So this is the blueprint, like class book is a blueprint. But how do you create object out of it is like this. Like this. You use a class, you pass the parameters. Parameters, where does this parameters go? It goes into this init functions. So if you are coming from C++ or Java background, it is similar to a constructor in those languages. But yeah, you can call this as a constructor, but this is not a true constructor in Python. There is some other function called as double underscore new. But for now, just um, uh, bear in mind that this is the first function, one of the first function which gets called during the object creation. So you have the blueprint here. When we do this book and we initialize, so and then we can call this function on that particular book. So we have created our own book. For example, let me try to run that program, book.py. So this has run. So it created a lot of objects, and this is run. Okay. So let me just drop a breakpoint here, so which we have learned it already, which means that we can stop the program and look at the variables and we can do some operations. Let me rerun this. and the command L will show you the list of um, above lines of code and below lines of code. And we are here at line number 54, where we have dropped a. We are at here. So it is telling that I'm going to execute this particular line if you press next. Okay. So let me analyze this book one, book two, and book three. What are they? So let us do dir of book one, which is an object that we have created. You can see that. So there are several dunder functions, which is double underscore functions. And these are the attributes that we have defined, which you can see it here, which are nothing but, which is in the blueprint. And there are also functions on top of it. Those functions are is open, mark, open, and so on. Okay. So all the attributes and functions are listed here, but you won't be able to know just by looking at it whether it's a function or an attribute. That is because even functions are objects in Python. Okay. So let us do one more thing here. Let us use type and just do v1, book one. Now you can see that it tells that the object of this type is coming from class double underscore main, because we are executing this particular module. Now we know that in one of our classes, what is double underscore main. We also use this to execute the program. Um, um, when you import the module, it should not get executed. So we have used if double underscore name is equal to main, do this or else don't do anything, right? So this is what it means. So we are in the main module, and within the main module, there is an object called as book, which is of type this class. So that is what an object means. So there is also an inbuilt function called as ID. So what it does is it gives us the memory location of that particular object. So this is mapped to a memory location in RAM. So you can see that all the books have different memory locations. Okay. So this is the beginning location of that book. So, and then this plus the size of this object is the place or the space that it consumes on the RAM. All right. So it's like your family goes to watch a movie. So you have got somebody who is sitting in the beginning of that particular row. So that is what is this number, and then the size of or the number of seats that you have your family has occupied for to watch the movie is like, if you are 5 members, that plus 5 is what this beginning seat number plus 5 is what is the size of your occupation or in RAM. So this place the size of this object. Okay. So that is what ID gives us some information. So that is why we are calling this as a blueprint. So this blueprint is used to create objects. So blueprint does not, um, it is not an object by itself, but yeah, technically it's an object internal in Python, but for your um, operation purposes, class means it's a blueprint. So object means you create object out of it and then it consumes memory. So that is what you should have in mind. So that's what is class and um, objects. Okay. I hope that is clear. So this is it is easy to understand because we are simulating the real world scenario using language constructs. Okay. So okay, that is about classes. Let me delete this. Let us get back to our test file here. So this is what it means. Okay. So there are ways. So you can also inherit one class from another class. For example, we created a class called as book, right? I can actually use um, this book as a base class and write a class which inherits book. Okay. I'll just show you what it is. So in real world, we inherit a lot of things, right? For example, when you say car, in your mind, it's just abstract. So, but if you say Mercedes Benz, it's a specific car. So it has its own blueprint. When you say it's Maruti car, it has company that particular company's car, and then you have several models. So you have a car which has common attributes. So those attributes you don't have to redefine in the classes which are going to be child classes or inherited derived classes. Okay, so all the objects or all the sorry, not objects, all the attributes that we have defined here in book are we don't have to rewrite again. It will be available automatically. Okay, so you can see that you can use the functions and attributes without even rewriting it. So that is one of the advantages of object-oriented programming, where you can inherit the attributes and the functions. Okay, so that is what is inherit means. So you can see that it has a specific syntax. So I have inherited book here for a class ebook, and then I'm using ebook. Okay, I don't have to worry about rewriting all these functions. So you can see that there are no specific functions for like open, close, and all these things, because it is already by default it is hidden here when you inherit it. Okay, so that is about inheritance. So if you look at this, that is exactly what is happening. So somebody has written a class called as test case, and then we are utilizing it in test calc. Okay, so this is the general syntax for writing test cases using unit tests. So give a moment, I'll just close the window. There is some drilling. Okay, let's get back here. So let us try to understand now how to test these functions using this. So now you have got a context and you understood the structure. Okay, so we have this particular construct, and then there are test cases here. So all the test cases in unit test, in that framework, it should start with this word test underscore whatever you can write. Okay, you can write anything else here. So it must start with test. I think you have to also include underscore, but generally what we do is we use this particular convention test underscore your function name. You can write anything. Okay, so let us say here what we are trying to do is this is just a new function which we have defined, and we are calling the function which is defined in calc.add. So we have written this model just a while ago, and we are calling that particular function calc.add, and then you're passing this. So these lines, which is self.assert and all these things. Self means it's the same object, which is like um, we have a blueprint and we have created an object, and when we can create multiple objects, right? So when we say self dot that particular this particular object and then call that function, in order to call the function which is defined in itself, it is defined here. So we use self as a it's not a keyword, it's by convention we are using self. So it is similar to this keyword in C++ and Java. Okay, so that is what we are doing here. So assert equal to which this particular function simulates or does what we discussed a while ago, where we called the function and then we had an if condition, And then we saw whether 10 plus 20 is equal to 30. So we assert this and then exit out of it if it's not equal. Okay, if it's not else exit. So that is what this particular function does automatically for you. So let us try to fail some of the functions and look at how it looks like. Okay, how the failure test cases look like. So let me just say, so this is your base code now. So what we can do is, so imagine that you have written this code like 1 week ago, and then you are trying to modify your code in some place, and then you did some modification. Okay, so now you think that uh, that this modification which I have written, so it should work. Okay, and then you push this code into your repository, GitHub, and or your company's repository, and in production, it's you get a bug saying that I'm trying to add two numbers, but it is giving me an unexpected value. So that is what happens in the production. But you can avoid this. So if you had written this, so you can see that this particular test case, which is written here in this line, so this is failing. So you have written test cases expecting that these two values should add up to this number. So, but that is false here. So if it is false, it will break the test case. And you can see that other test cases are uh, executed here. They are okay. So the moment it looks at fail, it just comes out of the uh, execution. So, so that is about assertion. What does assertion means? So what we have done effectively is that we have written test code, which is a verification code for our test or for our actual production code. So then you see that, okay, this is wrong. And then so this is just one line of code or one small bit that we have modified. But in reality, when you write features, you modify probably tens of lines and thousands of lines, probably if it's like a new feature and things like that. So that will have more complications. So, okay. So now let us try to, so this is about test case. So for every, so this is like your input versus your output. That is what you're trying to validate. Okay. For every function, you have a corresponding test case. Okay. So now let us go here and let us try to understand what a code coverage means. So I will. So whenever you write test cases, right? So this test cases, it calls this function. Okay. So when you call this function, this line is executed. So there are tools which will keep track of what lines have been executed in tests. So uh, what it provides, or what is the advantage of that is, for example, this particular line. So when you execute test for this particular function, so this line gets hit. So there could be some 10 lines of code, say, for example, here, line number 1 till 17. Okay. So you may add multiple lines here. So in future, in the this is your first change. In your second changes, you probably add 5 more lines here. Okay. And you may forget, or you may be in hurry to write test cases. Okay. So then you'll skip writing test cases for this. What happens is your test file this file runs and then automatically runs. So if you have set up the pipeline, or you can run it by yourself, this tells that all the tests are okay. Okay. but there is no surety that the new parts of the code is tested, which is like you have added new 5 lines of code, right? Lines of code, 5 lines. So how do you make sure that this 5 lines of new code is also executed? So that is where the code coverage comes into picture. So it tells that it gives the percentage of the coverage. So if you have written 10 lines and 5 lines are covered, 50% coverage. Okay. So if you have written 20 lines and then if tests covers only 5 lines, it is just 25%, right? So what in general the companies do or professional written code does is we keep some bar riser or we keep a gate saying that when you run these tests, you should have say 80% coverage, which means out of 10 lines of code, at least 8 lines of code should be executed in test you're using the test code. So that is what is coverage means. So let us see how it looks in Python. So there is a library called as coverage. I will let us ask ChatGPT. So I know how to use it, but I want to demo using ChatGPT because we are learning using this. Not ChatGPT, sorry, Copilot. Um, I want to use coverage tool to execute tests. Let it go. So in this directory. So, so there is a library called as coverage, which also comes up with an executable called as coverage. Currently, we don't have that. So let us try to install this library. Paste it here. Copy. Not using pip. So I have pip3. Just like our request library, and then this JSON is by default. So we installed several libraries, right? So we have this. So let us see if coverage is installed. So when I type the command coverage, you can see that now it is installed. Now we're getting some other output than this. So this command was not found. Since we installed using pip install, now we are able to run this command. So now let us try to understand what this tool does. So let me just copy this and paste it here. So this is the command to run the coverage or to run the unit tests using this coverage tool. So now we have just run directly, just like any Python file, right? Python, and then we are using this particular module. -m stands for module, and then we are executing this script. So other way to run the test scripts is using coverage. So let us, and it takes an input which is -m unit test, which we are specifying that this is the module that I'm using for unit test. So this does some magic internally. Let me show that. So it says that, okay, ran 4 test cases in like 0.0 seconds. So you generally will have like thousands of test cases if you have like large code base, and it takes like probably more than few seconds, like probably 20 seconds or something like that, okay, to run all the test cases. Depends on how you have written it. But let us see. This tells this. So once the coverage has run this, so advantages of running coverage is you can, so I'll show you. It also does dump something, coverage report. So if you just run this command, coverage report, you can see that for this particular calc.py, there are 10 lines of code, which is statements, and 0 is missed, 100%, which means coverage for us is 100%. So generally, we don't include test files for coverage. You can also exclude these test files because this is not the production code, right? So you can also say that, yeah, so there are some additional tools. For example, this can be converted to HTML as well. So let me just show you if that is there. Um, Report, I think coverage HTML. Let us see if it's already generated. I wrote report too. So, and then you can also open this particular thing. So this is a HTML file where you can directly just click on this and command click. I think it's opening somewhere else. Let me copy. Same report is it's here. Let me drag it. So this is the HTML page it has generated. Same thing, but it's in a different. So there are some additional tabs where you can see that these are the files and these are the functions which are covered. So which are covered: add function, multiply function. These are covered 100%. Okay. So this is what is called as coverage report. So what we do typically in industries, so in one of our pipelines, we say that if the coverage goes down than say 90% or 80%, fail the build. That means you won't be able to push this into the repository. So that is like a gate. Okay. So let us try to modify something here. Add adding numbers, some calculations. A is equal to not A is equal to something. So let me add some more functions. Okay. Add few more functions. Okay, this is just to demonstrate. You see that it has generated these functions: mod, power, square root, and so on. Okay, let me just copy it and delete all this. Now let us run the coverage again. So if you just run this test cases, so I'll just run without using coverage tool. I'll show the behavior. Of course, it ran 4 tests, and since you are the only person who is coding, you know that okay, these are the functions, and some functions, newly added functions, which are like absolute value, a square root, and power, mod. These functions are not tested. Okay, and then you think that there is no time to like test them, and then you just push in the code. So if you don't have the coverage tool which is running and which checks whether your coverage is not up to the mark, so this code will actually go into the production, and if there are some problems in this particular code, that cost of fixing the code in the production is more. That is because you have several lines of or several levels of people, right? So you're a developer, and there is like product manager who is the owner of the product, and when you deploy the product, there is like support team, and there are people who are managing those operations and so on. So those people are involved. So imagine if it is coming from customer, so the the work that is being done by all of these people, and then it reaches back to developer, the time that is consumed is more, and also there is cost involved, right? Because there is salaries and so many other things, infrastructure cost and so many other things. So cost of the bug in the field is probably like 1000x more than um, uh, you know identifying it in the development setup, because you're the only guy, or your development team can imagine those test cases and then write those test cases. Okay, so that is what is happening here. So let us run it through coverage now. So this is how we run the coverage, and there are 4 test cases. Now let us look at the report. Now you can see that it was initially about 100% here, calc.py, because we just had 10 lines of code. We have added 13 lines of code more here, which is 23. So that is the reason the coverage dropped down from 100% to 65%. So this gives us an insight about how much how many lines of code is untested. Okay. So this is one of the metrics. So there are several metrics. So the problem with unit tests is that it's difficult to cover everything. For example, if if the project is using some like hardware, which is like sensors, or it is getting information from an external API, like using a request library or something like that. So it is difficult to have all the setup in the local development setup, right? So in such cases, what we do is something called as mocking. So which is slightly a little bit advanced topic, but we can you can read about it later. Mocking is where you, for the external things or external part of the code, which you cannot actually have it. For example, if you want to test a sensor which is capturing temperature. So you cannot have that sensor at every developer's place, right? So you can simulate the behavior of that sensor. That simulation is called as mocking. Okay, so that we will cover, or you can read it later. But yeah, slightly advanced topic. So now we have understood that the coverage has dropped from some X percentage to Y percentage. So this gives us control over the code, saying that there is untested code, which makes sure that uh, the bugs are reduced in the production. Bugs are captured here. Okay, this is about coverage, and I think you can look at. Let me refresh if it's there. Okay, it has not generated HTML. I need to run one more command. So yeah, so what it does is it dumps some files here. So which is this one. So it automatically generates what is required for the web files. As we know that web is run by HTML, so it generates this particular um, code for HTML coverage. So if we go back here and refresh this page, now you can see that it is updated here. Coverage is 65%, and you can also exclude some of the files. So I'm going to exclude this test file. Okay, so exclude test file from coverage. We're going to exclude this test files because this is not the production code. So this is a verification code. Okay, so there is some command line argument where you can omit some of the files. So this is the command to, let me copy this and paste it here. So this is how you omit or you skip or exclude the files. Okay, so you say that omit test. So it also takes, let me run a report again. You see that this particular test calc is not counted for calculating the coverage. So overall is 65%. You can see that overall is 80% when we include this test calc. Okay, so since all the only production code needs to be put here, so I think you can also use some wildcards like this. No matches. Let me see. Omit. Use wild card for. So if there are like several, generally we'll have several test underscore files, which means test files, and you can exclude all of them together using a wildcard. So this is how a wildcard looks like. Okay, so let me just, yeah. So you can either exclude in this particular command line, so which is here, like this. Let me py. No matches found for. Yeah. You can also go to a configuration file here called text editor. Sorry, not this. You can also create a file called as .coverage.rc. Coverage RC, and then you can also include this line. Coverage RC. No. I hope this coverage RC. Coverage RC. Coverage RC. Now let us run it. Now let's look at the report. And report. In this, it's not picking up this file, but yeah, you can try out. So this is how you can exclude the files, but you understand the general idea. Okay, maybe coverage. Okay, coverage.rc it is. Coverage RC. Maybe there's a type or something like that. Not sure, but Control V. Yeah, you can try this. So that's not a to deal with, but you get the point saying you can use coverage to cover the code, and then you can exclude some files. So there are some more features, but this is good enough to write a coverage. Okay, so that's about coverage. Okay, I wanted to cover logging, but yeah. Okay, let us stop it here. So testing and coverage. And tomorrow we'll discuss about one small topic called as logging. Just to give an introduction to logging, I'll just tell you why it is used, and then we'll close the session for that. So you can, now we are using print statements to look at what's happening in the flow of the code, right? So print statement is designed to print something on the monitor. So this monitor, but all the applications that you are running won't run like we are running, which means that it runs in the background. So when it runs in the background, so these print statements won't go into the monitor. That means that program won't be able to print that into the monitor. Even if it prints, you won't be able to see because it's running in the background. So print statements are only for, like, your POCs and writing snippet of code and seeing how it works, the flow of the program. Okay, this is just for debugging, looking at this. So how do we capture the flow of the program, and how do you capture, say, if you have a function, and how do you know that this function is called, and this function prints some parameters, what are the values of those parameters, and then if something goes wrong, so if there is an if condition, say something goes wrong, and you need to specifically, so now you are printing, instead of that, probably you'll write something here, log that error, and we must be able to look at those errors. So that is where the logging comes into picture. Okay, so if you use the logging module, so generally there are like several levels of logging which we'll look at tomorrow. but there is a library called logging where you can, instead of prints, if you use this, these print statements or the whatever you want printing here gets printed to a file, and that particular file has a format. Within that, that data has a format, and it has got a like timestamp and so on, which we can control. So we'll look at logging tomorrow, but this is this is the reason why we need to know about logging, because prints won't work in the production. So if something goes wrong, if you're a developer, you will request for logs and then analyze those logs and compare that with your code. So of course you can use your Copilot to analyze logs. It does a really good job, which we'll see tomorrow. Okay, so that's about brief about logging. Okay, so that's it for today's class. Try out writing test cases and do code coverage. Yeah, which will help you to get an idea about, okay, what does a code quality means then. So this ensures one of the steps in the code quality. So if your test code covers about 80% of your code, you can have, of course, multiple test cases for a single function. So you can pass, say here we did, and here we have like one function each here, like, yeah. So these are the test cases. So because we are passing different sorts of numbers, like whether 10 is, these are positive numbers, these are like 0 and non-zero value, this is negative numbers, and so on, right? So yeah, so that is about, so every line that you write assert equal to is a test case. Okay, so every function has 3 test cases. Now of course you can enhance these test cases for your own. You can write more test cases to cover more use cases. But yeah, that's up to you. So we need to design the test cases before we write the code. So if all the test cases are running and if you have like code coverage about 80%, your code quality is really good. Okay, so that's about code quality. We'll look at logging tomorrow. Yeah. See you and have a great day.